Hi, fourth graders, it's Mrs. Compton, and today we are going to grab our whiteboard and our markers. So I want you to be able to rename these mixed numbers as improper fractions. So what that means is basically we've got a mixed number. A mixed number has a whole number, so this is a whole number, and then a fraction. So this means it's a mixed number. We're going to rename it as an equivalent improper fraction. So the improper fraction that is equal to 1 1/4. All right, so let's grab out our whiteboards. And you can write 1 1/4 equals, and then we're going to think about how we might change this into an improper fraction. So maybe some of you are thinking 1 is the same as 4/4. Is that true? Is this equal to 4/4? I can just pick any old denominator and then make the numerator worth the same. I chose 4 because this is already a fourth. So this is really equal to 1, and then I still have 1/4 left. It's kind of like a number bond, like that, right? You can think about it like that. And then we can see 4/4 plus 1/4 is 5/4, right? Okay, so let's write down 1/4. I actually want to write my number bond there. That's the same as 4/4 or 1, and then another 1/4. So that equals 5/4. Yes? Okay, good. Let's try another one. Let's erase. All right, here comes your next one. I'm going to give you one that has something greater than 1. 2 1/5. All right, so I want everyone to think about 2 1/5. How would you change that into an improper fraction? I liked what I did last time. I'm going to use fifths, though, because fifths are what I have here for my fraction. So I'm going to use 5/5 and then another 5/5. So that makes 1 2. And then I already have my 1/5 right there. So 5/5 plus 5/5 is 10/5. Plus another 1/5 is 11/5. Now, I bet some of you did this differently, because I bet some of you just put the 5/5 and 5/5 together, and maybe you just wrote 10/5. So it could also have looked like this if you were thinking about this in your head. That's the same as 2. So 10/5 plus 1/5 is 11/5. Either way, it works. Okay, so let's write that one down. So 2 1/5 is equal to 11/5. And we know that because we've got 5/5 for 1, another 5/5 makes 2, and then we already had the 1/5. Add them all up, and that's what you get. All right, remember, it's all about the number bonds. They save lives. Trust me on this one. All right. I don't know. Maybe you shouldn't. I'm just kidding. Okay, here we go. Here's your next one. I'm throwing a big one at you. Here we go. 8 1/5. How would you solve that one and turn it into an equivalent improper fraction? We're renaming it. So think about that one. 8 1/5. 1/5. All right. So let's think. 8/5. Wait a minute. 8/5 doesn't mean anything here. 8 1/5 is equal to, we would have to write 8/8. You guys, I'm messing this one up. 5/5. I'm going to use fifths because I've got this one right here. Okay, I would have to do that 8 times. So maybe you're starting to catch on that it's basically just the same as 5 times 8. But I'm going to write it out just so you can see. I've only got 4 of them. 5, 6, 7. I gotta squeeze one more in over here. 8. Okay. This is when it starts to get like, do I want to write it all those times, or do I just know it? So for me, I'm like starting to just know it, because 5, 10, 15, 20, 25, 30, 35, 40. 8 times 5 is 40. Plus the 1/5 makes 41/5. So basically I just used this denominator and I had to use it 8 times. So 8 times 5 is 40 plus 1/5. That was a lot of work. Okay, so I think for this one, I'm just gonna write 41/5. Okay, we've got one more coming our way. So erase your boards, get ready. I'm gonna give you something that has a fraction that doesn't have a 1 for the numerator. Get ready. Here it is. 2 2/3 equals what? All right. Okay, this time I gave myself some think time because last time I didn't give myself time to think and I messed up, right? So think time is important, kids. All right, I'm going to choose the denominator 3. 3/3, and then that makes 1. And another 3/3 makes 2. And then I have 2/3 already here. So 3/3 plus 3/3 is 6/3. 6/3 plus 2/3 is 8/3. Right? So we can rename 2 2/3 as 8/3. This one was just a little bit different because it didn't have a 1 for the numerator where the rest of ours did. But it didn't really change our process. We still used this to represent our whole number, and then we just added in the fraction that we had left. 3/3 plus 3/3 plus 2/3 is 8/3. All right, so let's write down that one. So 2 2/3. We could write 3/3, 3/3, 2/3. Add them all together and you get 8/3, right? Fancy schmancy. Okay, I'm going to write our story problem. I'll see you right back here in just 1 second. Don't go anywhere. Okay, we're back. Christina is planning a dance routine. All right, Christina, dancing. Got it. At the end of each measure of music, she will make a 1 1/4 turn. So she's going to turn all the way around, so like 360 degrees if you're a skateboarder, right? And then she's going to turn a fourth of the circle more. How many turns will she make after the first 3 measures of music? Okay, so basically she's going to turn 1 1/4 times 3 times, right? So 3 measures of music, 1 1/4 each of those 3 times. So 3 times 1 1/4. So basically we have to figure out how to solve that. Now there's lots of different ways. So this would be a good time to pause and think about how you would solve this, and then let's chat about some ways that the class might have solved it. All right, go ahead and hit pause. All right, so I'm gonna guess that some of you are trying out your new strategies, and I'm gonna guess some of you are using the distributive property. So did anybody break the 1 1/4 apart and then do 3 times 1 plus, so maybe you did that part first and then you did 3 times 1/4? Maybe you did that. 3 times 1 is 3. Hopefully we know that one, right? 3 times 1 is 3, and 3 groups of 1/4 is 3/4. So the answer here would be 3 3/4. Now, that's just one way. I've got more guesses, you guys. I'm going to guess that some of you tried out making your 1... Ooh, we actually already had 1 1/4 on our list. Maybe you tried using 5/4. So let's see. Maybe you did 3 times 5/4. That's the same thing, right? So 3 groups of 5/4. That means you would count 5/4, 10/4, 15/4. Ooh, and now we would have to turn that into a mixed number. So let's see, does this equal this? That's like kind of the big question. Are they the same? So 15/4, let's pull out one whole. One whole is 4/4. Let's pull out another whole, 4/4, 4/4. So that would make 8/4 so far. Can we pull out another whole? If we use another 4/4, 4, 8, 12. That would be another whole, 4 fourths. We've used 4, 8, 12 fourths. And then we have 12, 13, 14, 15 fourths left to go. So we only, well, take that back. Not 15 fourths left to go. 3 fourths left to go to make 15 fourths. So this would be worth 1. This would be worth another 1. This would be worth another 1. 1, 2, 3, and 3 fourths. Samesies! Okay, so that also works. That's pretty cool. I bet there were kids out there that did that. Okay. Maybe you even used a number line. I don't know how you did this in your heads, but I bet these were 2 pretty common strategies, right? The distributive property, and then also trying out some of the new things that we're learning, renaming mixed numbers as improper fractions. All right, kids, I'll see you next time. Bye.